Welcome everybody. This is going to be the beginning of our review for our final for midterms, and to cover a number of different questions. Every question will have video. So if you're just here for a review for the final, or you just want to know how to solve, in this case, exponential equations, I'm glad you're here, right? And if you find this video helpful, please give a like, subscribe to the channel, and leave comments about more videos or things you want me to do. Really appreciate any comments or input you can have for us here. All right, so we begin with the following question. Number one, 8 to the x plus 3 equals 32 to the x squared minus 1. Oh, so we begin with this case, first step we want to do is, well, first let me set the font here. Our step one is to find the common base. Find the common base. I'm typing this out because my handwriting is atrocious. Now, common base meaning usually we'll change the number 8 and 32 in a smaller base, raised to a certain power. And so in this case, we are going to determine that for both 8 and 32, our common base is 2. So 8 is equal to 2 raised to the third power. Okay, because 2 times 2 times 2 is 8. And 32 is equal to 2 to the fifth power. Now keep in mind, the common base is always going to be usually smaller than the actual number you're dealing with here. So if you're looking for example, 4, 4 would be a greatest common factor between 8 and 32. Actually, I think 8. Is 8 going to 32 easily? I think so. Yeah. Is it? Yeah, maybe. So the greatest common factor is 8 actually. So, but however, the idea is that common base is going to be how we can rewrite the base of the number to a smaller one, because we want to make sure they have the same exponent. Okay, so the same basis. Therefore, 2 or step 2. Oops. All right, just gotta make sure I set this up to the correct font size, and then of course put them in the right place here. So he drags over here. Sorry, ladies and gentlemen, just it's early in the morning, trying to work this out. All right, so our second step is in this case to replace the bases with our new numbers. Now, the same values, okay? So we're going to get, in this case, the equation will be 2 to the third raised to x plus 3 equals 2 to the fifth raised to the x squared minus 1. Okay? And so now, we have here is going to be, in this case, step 3, after we replace the bases with new exponents, we're going to now set the exponents equal to each other. Now, the key thing is this, equal to each other. Okay, and the key thing in this situation is going to be that when you raise a power to another power, you're supposed to multiply the exponents. Okay, so we multiply exponents here. So our new equation will be not x plus 3 equals x squared minus 1. That would be a very big error. And so instead, it'll be 3 times x plus 3 equals 5 times x squared minus 1. Because the bases are the same, the exponents are the same, because it's an equation. All right, and of course, our last step here, step 4 is to solve the new equation. All right, and again, we're solving for x, and we were still solving for x before, so I said line this up so it's nice. It's just okay, there you go. All right, and so we're going to solve now. All right, and so in this situation, we're going to distribute. So we'll distribute here the 3 with the x plus 3 and the 5 with the x squared minus 1, and we shall get 3x plus 9 equals 5x squared minus 5. So at this point, it's a quadratic equation, so I'm definitely going to move items over to one side, set the equation equals 0. I like having my x squared be positive, so I'm going to subtract 3x on both sides, and as well as subtract 9 on both sides. And so we're going to get, in this case, 0 is equal to 5x squared minus 3x minus 14. All right, so we want to find, in this case, this is factorable. Well, let's take a look. I know 5x squared is really 5x times 5, so 5x times x. And now numbers that multiply to 14 are definitely going to be 1, 14, and 2 and 7. And so I'm going to now keep in mind that the signs for the numbers had to be opposite because I'm getting a product of negative 14. The inside terms will add to negative 3. So if I want to add negative 3, I'm going to put a 7 here and a 2 here. And so I see in this case, I got 5 times 2 is 10x. Right? And then 7 times x is 7x. And I want a negative 3x as a sum. Well, if I make this negative 10 and positive 7, I get this work out. So we have 5x plus 7 and x minus 2, right? X minus 2. And this is equal to 0, all right? So you want to kind of, in this case, there are other techniques we can use for solving, so in this case, factoring a trinomial where the a value is not 1, including the factor by grouping method. That's fine too. You can solve this using quadratic formula. I just want to solve by factoring because it's a little more expedient. It's also a good skill to know. So we're now going to set these factors equal to 0. So we have 5x plus 7 equals 0, and x minus 2 equals 0. And of course, for 5x plus 7 equals 0, I subtract 7 to both sides to get 5x equals negative 7. Divide both sides by 5. X is equal to negative 7 over 5. And if I add 2 to both sides of the second equation, I get x equals to 2. And so those are my two solutions for this problem. Okay, and so this is the full page. We'll take a look at this now. All right, so again, we want to change the bases to equivalent numbers with smaller bases. We're not changing the value. The value numbers haven't changed. However, because now the bases are the same, we can set the exponents equal to each other, because in exponential equation, if the two bases are same to each other, equal to each other, then the exponents must be equal to each other as well too. Okay. All right. I hope you guys enjoyed this video. I hope this is helpful. Will every question be quadratic? No. But the process is that we have to keep in mind that we ought to be able to solve quadratic equations as well too. We have techniques for that as well. You can check other prior videos we have for solving quadratic equations, like quadratic formula or factoring. And again, if you found this video helpful, please give a like. If you stuck around to the end, that's great. I appreciate it and all. And leave comments. I really appreciate your comments. Some of them, any criticism, I appreciate as well too. And just knowing that you guys would like some more videos or about any particular topic, just say, hey, can we work on the topic as well too? I did get a request for something else, and I'm going to try to work on that as well too, ladies and gentlemen. So thank you so much for watching. I will see you in the next video. Take care. Be safe.